Hello everybody. Thank you for joining the course on the introduction of mudcrab vertical farming. In the previous lectures, we've talked about biofiltration and the different technologies that are used in processing the waste in the nitrifying system. We talked about trickling filters, fluidized bed, and as well as moving bed reactor. In this lecture, we will move on to focus in preventing pathogens in your recirculating aquaculture system. Proper disease control procedures is very important in a recirculating aquaculture system. It is because you are farming at an extremely high density, and any outbreak of diseases coming from bacteria, viruses, or parasites would have a catastrophic impact on your yield. The idea of disease prevention and control in a RAS system is to adhere to the prevention is better than cure. Firstly, you need to avoid the introduction of pathogens by buying from reputable producers and also choosing crabs that are fit to be farmed in the aquaculture systems. Decontamination of RAS system is extremely difficult. We will explain in a little bit. Diseases can have varying economical impact on the business. Firstly, we always see a reduction in growth rates if the crabs are manifested with parasites, bacteria. Reduction in feed to conversion ratios, resulting in excessive feed costs. Thirdly is the mortality. Sometimes disease can also impact the product quality, and this disease is commonly known as the bitter crab disease, as well as lost opportunities. The first point of disease control is biosecurity. Usually, do not let visitors to visit your farm, especially if they are farming crabs on their own. This is to reduce the possibility of passing potential pathogens from their farm onto your farm. Do not let any visitors touch the water in your tanks that might potentially transmit any form of bacteria or viruses into your system. Make sure all your ground staff wash their hands and disinfect regularly. Pest control such as cockroaches, rodents needs to keep in check. You will also need a quarantine area for incoming fishes and any incoming crabs. Crabs have to be disinfected with potassium permanganate at 2 ppm for 30 minutes. This is how you disinfect the crabs. You place them in any cylindrical or rectangular tank. Add the correct amount of water followed by potassium permanganate at 2 ppm and disinfect them for 30 minutes. Remember to provide them an airline to provide the crabs with oxygen. These are some of the crabs that are manifested with parasites. This is what we call rhizophilum barnacles. Over here, we can see that the gills of the crabs is infested with nematodes. Make sure all of your nets and tools that are frequently used, especially if they contact with crabs, and make sure they are disinfected regularly. What do you do in the event of diseases? Firstly, what you could do is to reduce feeding and improve the water quality. Usually, if your host and your environment is in an excellent condition, even with pathogens, there will not be a disease outbreak. Using medicated feed will sometimes have adverse impact on the biofilters. For example, usage of antibiotics are not recommended in RAS systems, as the antibiotics will not only kill off the pathogen, but it will also kill off the nitrifying bacteria that is used in the biofilters. Another way is to reduce the treatment temperature. By reducing the temperature, you reduce the growth rate of the bacteria, allowing the fish to fight the disease on its own. In the impact of diseases, try to perform a CFU count. A CFU stands for colony forming unit, and it gives you an indication of how much bacteria you have in the system, and try to isolate the bacteria to know what you're dealing with. Check on your UV functionality. The typical UV light lifespan is about 10,000 hours, which equates to about 10 months. In any recirculating system, there will be UV process embedded in the system. The UV destroys any DNA of any pathogen, regardless of bacterial or viral in origin. The UV that are utilized in the reactors are called UVC, and it has a spectrum of 200 to 280 nanometers. However, it is confusing as the bacteria require certain UV dosage manifested as flux. But if you were to talk to the suppliers on sizing UV, they typically give you a benchmark of 1 watt per 1 meter cube of water. However, this is just a rule of thumb, as the UV light voltage does not give an indicator on how much UV dose is actually reaching the pathogen. To illustrate my point, this is a chart between UV transmission, UV dose, and UV transmission. As you can see, when the transmission percentage drops, the UV dose actually reaching the pathogen decreases. So what are UV transmittance? Transmittance is a mechanism which affects the transfer of light from the UV light onto the water. For example, if your suspended solid removal control is not done well, you will have a lot of fine particles that is floating around the water. Now, imagine your UV light trying to disinfect the water. But since your water is filled with suspended solid, it is not likely the light from the UV source can reach the pathogen, resulting in a widespread of pathogens in the system and your UV light useless. That is one form of reducing transmittance via turbidity. Sometimes there are other methods. For example, excessive organics in the water would also decrease the UV transmittance. One common problem we see in UV reactors is due to calcification. As you are running your RAS systems in saltwater condition, it is common for calcification to take place. Once calcification takes place in the UV lights, the UV is no longer reaching the pathogen effectively, and hence reducing the transmittance value. And in return, reducing the actual UV dose that is used to kill the bacteria, rendering your UV ineffective. To have an effective UV transmittance, not only your UV light needs to be sized correctly with a low residence time, but your previous processes such as solid removal and biofiltration needs to be done well. Note that the UV effectiveness is very dependent on the previous unit processes. How do you operate a UV light? Firstly, you need to routinely check the sleeves for any deposition, mainly calcification or any form of deposition that might render your UV transmittance lower. We also proactively change out the UV lamp every 8 months, about 1 to 2 months before it is end of life. Residence time, speed of fluid flowing through the reactor is also important. Increasing velocity or increasing flow rate throughout the reactor would mean that it has a slower contact time, meaning that the pathogen will not be effectively destroyed. In the market now, we have seen a rise in ozonation. So ozonation is a water treatment process that destroys microorganisms and degrades organic pollutants by a gas produced by subjecting oxygen molecules to high electrical voltage. Ozonation, on the other hand, is toxic. However, it can be degraded with UV. So we have seen a lot of suppliers in the market who have tried to sold systems where they have ozonation first, followed by a UV system. And this dual system of ozonation and UV seems to be the perfect combination. In our plant, we are only utilizing a UV light, and the UV light we are using is about 90 watts. We have to proactively replace the UV light every 8 months. In some water treatment processes, it is common to include additional filtration steps such as microfiltration or ultrafiltration prior to the UV plant, or in our case, we are utilizing what we call a protein skimmer to remove any fine solids before it is introduced into the UV system to ensure that our UV is at its peak performance. So that's all for this lecture. In the next lecture, we will show you how all of these different unit processes work together to perform what we call the recirculating aquaculture systems.